Okay guys, how are you? I hope all is fine. I just wanna share you with another video about an abstract and it's on the first symposium doctoral student organized at IIT Kanpur. The abstract is about effect of transverse product loading on an airfoil in a cascade. MC Kirti and Abhijit Kuseri, graduate student and associate professor, Department of Aerospace Engineering, IIT Kanpur, UP, India 208016. Extended abstract: aircraft gas turbines engines are being subjected to increasingly severe requirements in terms of thrust to weight ratio. The blades of axial turbo mechanics are therefore subjected to higher loading while the blade thickness is getting smaller. As a result, strong fluid structure interaction results between the unsteady airstream and the vibratory blades. Due to the effect of adjacent blades, the aero-elastic phenomena in turbo machine establishes in a manner different from an isolated aircraft wing aero-elasticity. The present study is a preliminary CFD study of damping performance for a compressor cascade over a range of relevant parameters. And introduction: present-day aircraft gas turbine engines or designs are tending towards maximize the performance at lower cost without compromising on safety. In the context of aerial turbo machines, this entails having timer blades while being subjected to the same or higher aerodynamics loading. Due to the high relative velocities encountered, this can lead to a self-starting and sustaining blade vibratory phenomena called flutter. The prevailing unsteadiness in the airstream due to the upstream rotor wakes or gusts can lead to blades vibrating at their natural frequency, known as forced response. Both flutter and forced response cause higher cycle fatigue, leading to catastrophic blade failures. The current predictive tools for aeroelasticity in turbo machines are not adequate, possibly resulting in a costly redesign of the blading in the later stage of engine design. Some of the critical parameters in turbo machine aeroelasticity are the interblade phase angle and the reduced frequency. The present study is a fundamental CFD study on the effect of interblade phase angle on the damping characteristics of a reference stationary airfoil. Formulation: in an actual turbo machine, the blades vibrate with a non-zero phase difference with each other. This is enforced by the nodal diameter of the rotor disc, resulting in a constant phase difference between any two adjacent blades. The phase difference between the forces acting on a vibratory blade and the motion of the blade is a critical parameter that decides whether the amplitude of the blade vibration can grow in time. The network done on the structure is a function of this parameter and its sign. Its sign is a direct indicator of instability. In the present study, only the effect of the oscillating neighboring blades on a stationary airfoil is studied. The cascade under study consists of 5 airfoils with a spacing of 60.5 mm, and the airfoil is a standard test configuration 1, recommended for a low speed compressor. Aeroelastic studies, and that is Bolks and Franson. The camber oil angle of the airfoil is 10 degree and the chord is 121.7 mm. The stagger of the blade is set at 0 degree. In the present study, the second and fourth blades were oscillated about the mid-chord, while the third blade is chosen as the reference. And ANSYS CFX is used for computing the transient solution. The effect of the phase difference between the neighboring blades is referred to as interblade phase angle. The reduced frequency is defined as K, which is BW over U, where B is semi-chord, W is the blade oscillation angular frequency, and U is the inlet velocity. The damping parameter is a function of the phase difference between the blade force component, lift or drag, and the blade oscillation motion. Conclusion: a moving boundary model has been implemented and tested in ANSYS CFX. Simulations have been conducted for 3 values of reduced frequencies and 4 IBAs. Regions corresponding to high and low damping for axial, drag, and transverse loading lift have been identified using the phase difference information of the periodic loads. So this information is useful when we are talking about the effect of transverse periodic loading on an airfoil in a cascade, and you can actually go through this piece of information which may help you to actually understand this phenomena at a research, PhD, or even at a graduate student level. We're going to find you with another interesting aspect of some of the abstract or this is symposium primarily. Till the next video, take care and have a nice day.